Hello, my name is Georgia Warren, and this is my solution to bonus problem 1. As you can see from the diagram, in bonus problem 1 we have a vessel on the left firing a projectile over a mountain on an island toward the vessel on the right. And we want to find over what range to the right of the shore of the island the vessel is protected. I have started by writing the equations for the y and x positions as a function of time for the projectile. Then, from the diagram, you can see that when the y position is 1800 meters, the x position will be 2500 meters as the projectile is passing the top of the mountain. We can use the equation for the x position, and equating that equation to 2500 meters, we can find that the time at which this occurs, the time at which the projectile passes the mountain, will be 10 divided by cosine theta. Substituting this time back into the equation for the y position, we then obtain a equation for the y position in terms of tan theta and cosine theta, which I have equated to 1,800 meters, or the height of the mountain. From there we can use the trig identities. 1 on cosine squared theta is sec squared theta, and sec squared theta equals 1 plus tan squared theta, to obtain our quadratic equation in terms of tan theta, which can be solved to find the two angles, the maximum angle and the minimum value angle for which the projectile will be able to pass over the mountain with the given initial velocity of 250 meters per second. Solving this quadratic equation, we get two values, the minimum value theta L and the maximum value theta H. We know that the minimum value for x will occur with the maximum value for theta H, because velocity will be maximized in the y direction and minimized in the x direction, while still allowing the projectile to pass over the mountain. So using theta is our maximum theta H value, 76 degrees. We substitute this into the equation where the tan of theta H is equal to the height of the mountain divided by 300 plus x meters. And we're trying to find x meters as the length past the shoreline of the mountain for which the vessel is protected. So using this, we simply rearrange the equation for x and are given a final x value of 1.6 times 10 to the power of 2 meters to two significant figures, because the value for gravity that we used was to two significant figures in our calculations. And what we get is that the vessel is protected for 160 meters past the shoreline of the mountain.